Hello and welcome. My name is Victoria Sazarski, and I'm the Webinar Production Assistant for Dataversity. We would like to thank you for joining today's Dataversity webinar, Data Quality Engineering. This year's April edition is a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Now let me give the floor to Megan Jacobs, the webinar organizer from Data Blueprint, to introduce our speaker and today's webinar. Megan?
Thanks, Victoria. Hello, everyone, and welcome. My name is Megan Jacobs, and I'm the webinar coordinator here at Data Blueprint. We are pleased that you found the time to join us for today's webinar on data quality engineering. As always, a big thank you goes out to Dataversity for hosting us. We will get started in just a few moments after I let you know about some housekeeping items and introduce your presenter. We have a 1-hour presentation followed by 30 minutes of Q&A. We'll try to answer as many questions as time allows, but feel free to submit questions as they come up throughout the session. To answer the top 2 most commonly asked questions, yes, you will receive an email with the links to download today's materials and any other information you request during the session within the next 2 business days. You can find us on Twitter, Facebook, and LinkedIn. We've set up the hashtag DataEd on Twitter, so if you're logged on, feel free to use it in your tweets and submit your questions and comments that way. We'll keep an eye on the Twitter feed, and we'll include answers to those questions in our post-session email. Now, let me introduce you to our presenter. Peter Aiken is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. Peter is also the founding director of Data Blueprint. He has written dozens of articles and 8 books. The most recent is Monetizing Data Management. Peter is experienced with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his and Data Blueprint's expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. He often appears at conferences and is constantly traveling. Peter, what are you up to this week?
So this week I am the guest of the Federal Communications Commission. So when we're talking about dirty data, we don't mean really dirty stuff, those of you that are listening on this. The key is we're just in town for a little bit of work here, and I'm sitting in a beautiful office at the FCC headquarters looking out over the Potomac, watching the airplanes take off from Washington Airport on this. Again, it's kind of fun because everybody does end up with some interesting data quality challenges, and so the FCC is no different. They also have data quality challenges, as everybody does. And this is what we're going to talk about today is always start out with a data management overview, and I'm going to give you a definition of data quality engineering with a very specific example so that you understand contextually what we're talking about here. Then we're going to go through a data quality engineering cycle, and we'll talk about some complications that occur with that. And the main one is, of course, data quality problems manifest themselves in a myriad of ways. And because they manifest themselves in a bunch of different ways, it requires a bunch of different methods to look at them. Section 4 then will dive into the clauses and dimensions of data quality because there is a cause and effect relationship that we need to be able to understand and know which group of techniques to apply as we're looking at this. We'll then talk to quality and the data life cycle and talk about how our thinking on that has evolved over time, and finish up at the top of the hour with some definitions of data quality engineering tools and things. And then, of course, the part I look forward to is your questions and answers, because that's sort of how we take the pulse of what's going on out there in the world is based on what types of questions you guys bring to these things. And every time we do it, we enhance the presentation as a way of saying thank you for giving us the feedback and telling us the things that you're interested in. So let's move right in. First of all, I always start this out because most people don't get this particular picture when they're talking about data. Now, remember, data management is the process of grabbing data at the source and getting it all the way to the destination as quickly and as effectively as possible. And this rather complicated diagram, which we tend not to show to managers, is what it means to do data management right. There's a lot more detail that goes on around this, but I'm going to simplify it for all of us on the call here for just 5 areas. The first one is making sure that we're all literally singing off the same piece of paper. Now, the idea here is, of course, that you have lots of good data management initiatives going on in your respective organizations, and these people are very good at what they do, and they try really, really hard to do it well. However, one person can accomplish some things. Everybody pulling together in the organization and focusing on a very specific goal can accomplish much, much more. So it's getting everybody on that same sheet of paper and trying to attack the same goals in whatever budget cycle that we're working on. The second area of data management then is to look at organizational data integration. And the idea here is, of course, that we're sharing data across boundaries, whether it's from one program, as in a software program, to another program, whether we're moving data from transactional systems to a warehouse, whether we're sharing data between different departments of the organization to another organization, or whether we are sharing data between our organization and our business partners. We are sharing data across boundaries. If that process is happening unmanaged, there's no way it can be optimized. And if it can't be optimized, it means you are losing some resources. Our research shows that you're spending 20 to 40% of your IT budget working in these two areas on the top. This doesn't bode well for most organizations, although, again, if you look at it from the positive angle, if you save some money by doing this, you will actually end up with your organization saying thank you. Now, the question of who to say thank you to is an interesting one as well. And what we typically think of in today's environment are the data stewards. They are the people that are assigned responsibilities for some portions of the data. Until it says, in most data problems, people think of data quality as being everybody's problem. Well, that's a nice thing to say, but it's not really true in reality. And if we don't reward people for fixing things, then they will not fix things. So what we have in this situation is the minute it says, Peter, your next raise, your next promotion, your next whatever is going to depend on you measurably increasing the quality of this portion of the data, it's never going to happen. So these data stewardship functions, while they are relatively new, are now becoming more commonplace. They are in more organizations now than they are not. The fourth area is data engineering, which is the process of taking and understanding how to build systems. In the past, this has always meant building relational database management systems. In today's environment, we have a lot of other things that we can bring into play, which are different data delivery systems, all kinds of other alternative portals, XML, different things that work in that area. And finally, data systems, just like our automobile and transportation systems, need constant maintenance. If we don't maintain them, they have no ability to continue to deliver. They become out of tune, they become bloated, they become inefficient. Again, this is what we mean by integrating these 5 data management practice areas. It's another important concept as well, which is that most people think that data management is what goes in this green triangle here that I have on the screen. The green triangle represents really, in our mind, the tip of the iceberg. We call these the silver bullet technologies, things like cloud, master data management, big data, whatever it is that we're talking about. Unfortunately, though, these things are really just the tip of the iceberg, or we also talk about them in terms of Maslow's hierarchy of needs. If your food, clothing, and shelter needs are unmet, it is very unlikely that you will turn around and self-actualize at night. And data management is exactly the same way. Without the basic data management practices that I've taken off that previous chart and put on the bottom here, really the bottom of the iceberg, the part that most people don't know and appreciate, there's absolutely no way that you can succeed at the top within the parameters that most organizations have. The question we get from a lot of organizations after we explain this to them is that they say, well, I don't want to do that bottom part stuff. Can I just do the stuff in the green triangle? And the answer is absolutely yes, you can do it, but it will take longer, cost more, deliver less, and present greater risk to the organization than if instead you learn to crawl, walk, and run your way to the top of that process. Some of you are also familiar with the DAMA body of knowledge, the DMBOK as we call it. You like to think it's analogous to the PMBOK, and it has in fact become the de facto standard for talking about this. And I have to tell you a funny little story on this, because if you notice from my diagram here, the data quality piece is actually the last chapter in our DMBOK. And if there's one thing that we shouldn't have done was put data quality as the last chapter. You can see it right up there at 11 o'clock on your screen there, talking about data quality management. And frankly, right now, the state of the DMBOK 2, the revision that we're working on, also that chapter is the last chapter. We're going to fix that because we simply can't let the data quality piece be last. It's just one of those ironic things that's hilarious for us to have put together. There are about 2,000 people worldwide who have passed our CDMP exam. It doesn't compare to the vast tens of thousands that have gone through and passed their PMP certification, Project Management Professional Certification. But we are starting to see places like the federal government in Washington, D.C. here, where they are asking for people who are qualified, who are certified to be able to work in this area. So this is our attempt to start working on this from a professionalism perspective. Now, in the DMBOK, the Data Management Body of Knowledge, the chapter on data quality engineering, in fact, starts out just exactly like this. What you're looking at is an input-output process diagram that shows the inputs, and you can see them down the left-hand side, the activities that are in the teal box right there, the outputs, the deliverables that are there, and then, of course, we have goals and participants on the top and the bottom. And this is basically comprising the subject material that we're going to talk about. And also, I've superimposed now those same data management practice areas in there, so hopefully that gives you an idea of the connection all the way around on these things. Let's move on a little bit now and get to a definition. First of all, we always ask the question, if we're going to talk about data quality, what do we mean by data just for starters? And the answer that I give to most people is the number 42, in which case people usually look at me like a dog looks at you when you try to explain something to the dog in English. But 42, for those of you that don't remember, is the meaning of life, the universe, and everything. It's from The Hitchhiker's Guide to the Galaxy. It's a really fun little book. Some of you undoubtedly on this call are chuckling with good memories of a really good read. The rest of you are thinking, Peter's crazy. Well, Peter's not crazy, but what he has done is give a little bit of meaning to the number 42, which before you saw this slide was just a fact. Now you know, at least in Peter's mind, and those of us that have read The Hitchhiker's Guide to the Galaxy, we understand that 42 is the meaning of life, the universe, and everything, and that is what we mean by data. 42 as a fact is kind of useless. It's also my age 13 years ago. Not that that would have anything to do with anything you're doing from a business perspective, but it's the same fact with a different meaning. When we take those facts and meanings and pair them with requests, we get what we call information. And this is the big mistake in IT, because we think that that first understanding, the superficial understanding that we get from most of our requirements exercises actually represents what it is that we're doing with the data in the business. Turns out it's actually a lot more complicated than that. We have to go to a third layer, which is intelligent use or strategic use of the data. Once we've gone through that iteration, we now understand that it's not what we think we need to use it for, it's how we observe the businesses, the organizations using this particular data. Now, you'll also notice here that there is a structure here. It is impossible to do intelligent use of data without first understanding how data is structured, which is the bit about getting facts and meanings together into some information, and how that information is managed internally in your organizations to be able to do this. Again, hopefully this chart will help you. I've had a lot of people that request it. I did not create it. If you look in the bottom right-hand side, a fellow named Dan Appleton, who I worked with in the 1980s, did a great job of explaining this, and everybody loves the particular chart. So now you know what data is. Let's talk about what data quality is. We have a very simple definition that we use. Most everybody I know that works in this space says data is fit for use. Now, fit for use means that it's okay to use when you need to use it. Again, remember our life cycle is where the data is captured until the data is used. Everything in between we call data management. And I'm going to tell you a little story about spinach here that I find absolutely hilarious. You know that people for years and years have said, eat your spinach because spinach is high in certain vitamins. You know what? That's actually a data quality error. Turned out it was made here in Washington by a group in one of the federal agencies who made an error. They made an error when they were calculating, and they thought that spinach was 10 times more potent in its vitamin and mineral content than other vegetables. It turns out it's not. So all this talk about spinach for years and years and years is absolutely based on bad data quality. They corrected that, but of course the myth got out there already. In data quality, it's also appropriate to talk about information quality, and really the two are synonymous. I would prefer people choose one or the other, but not try to split hairs and find them out. One of the other messages about the diagram on the previous page is that if you're trying to manage them separately, you create more work for you than if you try to manage them as an integrated whole. Now, we know what data quality is. Let's talk about data quality management, which is the activities that apply between the time we collect data and the time we deliver data that allow us to improve, assess, measure, and ensure data quality. It also means we have some risk, roles, and responsibilities that go into it as well. It is absolutely critical in this context to make sure that you have support for change management, and also understand that it is not something you do once. You can do different levels of it, but data quality management is a continuous process. Now let's move on to the term that I really like, which was where most of the understanding stops, and that is that data quality must be engineered. It has a discipline that applied to it just the same way as the building I'm sitting in that is overlooking the Potomac also has some engineering components that go with it. If it wasn't engineered, this building would slide into the Potomac River. Again, we have definitions of engineering, but these concepts of engineering are not generally understood either within IT or the business. And that means our job as data quality engineers is a little bit harder. We have to do a little bit of education around this. Let me give you a very specific example on this. This is one that we did across the river here for the Defense Logistics Agency. And the challenge that they had were that there were millions of NSNs, or as non-government folks know them, SKUs, stock keepers units, that were maintained in a catalog. They were moving the system to a big ERP, and they needed to get the data out of this catalog, but they couldn't just export it because the data was stored. These millions of NSNs were stored in clear text comment fields, blobs, if you will, that were out there. So they made a decision that they should manually approach this and have individuals sit down and go through each of the 2 million NSNs and SKUs to pull this information out. Now that would have extracted the information, however, it would not have helped them with the structuring problem. The solution I want you to understand is, in this case, what we would now call text analytics. Many people are very fond of that particular term, and it's a very good term. We didn't call it that in those days. What we were really doing was converting this non-tabular data stored in the comments fields into tabular data that we could put back into the database and find it. And I was really proud of this, not because we saved the government $5 million. As a taxpayer, I'm, of course, all about saving the government money, but it was the first time, any time I had done this work, where we saved people a person century of work. Now, I'm going to show you this chart here, which is a little complicated. It's got a bunch of numbers on it, but I'm going to show you we also figured out how to identify the point of diminishing returns where the problem ceased to be an engineering problem and could be turned back over to manual intervention. Numbers are pretty easy. We held the left-hand column constant. It was 2 of our data engineers' time, working 20 hours a week on the problem, so that was a fixed cost. And the first week, we were pretty bad. We didn't match anything. Of course, this means we have to move into the expectations game because we don't ever want anybody to think we're going to solve the problem with the absolute first week we approach it. On the other hand, by week 4, we had identified 55% of the data that needed to be extracted from this and been able to demonstrate that we could extract it. So after 4 weeks, we had solved half the problem, a little more than half of the problem. In addition to that, we'd also determined that some of the data in there was ignorable, and you can see that represents 12% of the problem, and we were then tracking our unmatched, what's left over. And you can see that was varying. It went up and down, which meant we were still fine-tuning our algorithms for data quality. Now, the question was, we had week 4 solved half the problem. When do we stop? When do we get to the point of diminishing returns? When can we identify specifically that we were getting less out of it than we were going to put into it? And that's the point at which we wanted to stop. Turned out for us that was week 18. You can see that by week 18 we had actually gotten the unmatched problem down to 7.46%, 7.5% of the data was simply unrecognizable by our text parsing algorithms. Our ignorable items, however, was very flat. We had gotten them to 22.6%, so we could ignore 1/5 of the problem right away, and you could see our proprietary improvement algorithm got to 70% of the problem. So if I can throw away 22% of the data and I have 70% that I can solve, my original problem here is much smaller than it was when we started out. Over the lifetime of this project, we put a measure of 5 minutes on, which is 10 million minutes to clean. You can see we were going through all of these calculations here, but the important one is the one that's on the screen now. The total person years were 93.6 person years. We then multiplied that by a general salary, came up with $5.5 million. And one of the fun things to do with these is to present this to management as a plan, and they say, oh, great, that's wonderful. It sounds like a good idea, but what's the most important number on this chart? It turns out the answer is 5 minutes. I don't know any data quality engineers that can fix these problems in 5 minutes apiece. So if I double this from 5 minutes to 10 minutes, I now have 2 person centuries and $10 million. If I triple it to 15 minutes, again, 3 person centuries, $15 million here. Now, I've told you a very simple story, but I want to be careful and not leave you with misconceptions about this. And this is a wonderful source of one of the typical things that you see in the professional trade magazines where it says, hey, you can fix the problem. Data quality is an IT problem. The problem is with the sources of the entry. A data warehouse will give you a single version of the truth. The new system will give you a single version of the truth. Standardization will eliminate these problems. All of these things are true, but they are not going to get to the root of the problem. And the reason for that is because data quality manifests itself in a number of different ways. You've all probably heard the apocryphal story about the blind people and the elephant. Somebody approaches the side of the elephant and says an elephant is a wall. Somebody else picks up the tusk and says, no, it's a spear. Different people from different backgrounds correctly understand data quality in very, very different ways. This leads to confusion, disputes, and very narrow perspectives on it, which means we can't share these challenges holistically within the organization. Remember, data is our sole non-depletable, non-degrading, durable strategic asset, and it needs to be measured and managed as such as well. The solution is, of course, data quality engineering that can help you get a more complete picture around this and help cross-boundary communications on this. Our focus here is on allowing the form of the problem to guide the form of the solution to provide some means of decomposing the problem. It features a variety of tools for simplifying understanding of the system. It offers a set of strategies for evolving the design solution, provides criteria for evaluating the work. I won't read these, you can get the picture, but we're going to ask you guys a question. We do these polling questions in here, and we want to know, because we track these things year over year, does your organization plan to address or is already addressing this particular solution? We'd like you to take just 30 seconds here and give us your feedback on this so we can help to orient our future programs around this. So if you take a minute and just sort of say, hey, did we get it this year? Did we get it last year? Will we do it next year? Or we hope to next year. We'd love to get this information out. Gosh, Victoria, looks like I can vote on this one. Maybe I'll do that. Probably not a good idea on this. I'll leave the question up here. If I had my phone ready, I'd play the Jeopardy theme music, but you guys know what that sounds like, so I won't do that as well. We will pop the results up here, of course, as soon as we finish. So, Megan, I can't see the timer on this. When are we at 30 seconds here?
All right, it looks like we have all the results in. Let me get the poll results.
Pop them up here for us.
Give me 1 second.
Megan's working really hard behind the scenes here. She's counting the votes manually, right, Megan?
Oh, yeah. Yep.
There we go. Okay. So, again, we did last year 15% of you. We are this year 33%. We will next year 4%, or we hope to next year 12%. 36% of you are keeping your heads in the sand because you don't want to get in trouble with your bosses. We certainly appreciate that. Again, thank you for the input there on that. It's very interesting. It actually seems a little down from last year, so hopefully we won't see that. Let me give you another example of data quality. This is an absolutely infamous example, made the rounds in Japan and actually worldwide in the financial community. The key here was that this company called Mizuho Securities had a trade that they wanted to execute, and the trade was to sell one share for 600,000 yen. Yen, of course, come in many to the dollar. It's about 3,000 English pounds in this particular example. However, the trader had a bad day and sold 600,000 shares of the stock JCOM for 1 yen. What was worse, $350 million loss, and the in-house system did not have limit checking. Data quality problem number one. The Tokyo Stock Exchange did not have limit checking. Now, limit checking would have prevented anybody from trying to sell a stock for as little as 1 yen, which, as you can tell from the math, would have been a fraction of a penny on this. What they did, however, what they didn't also have was the ability to cancel the orders. So when they tried to cancel the order, there was simply no way of canceling the order. They were not able to do so, and the trading firm, in this case Mizuho Securities, absolutely ended up with the whole thing, eating it. Now, again, we go back to the trade magazines where people don't really get this stuff. So you see these articles again. Well, here's 4 ways to make your data sparkle, right? Prioritize the task. Great. Involve the data owners. Absolutely. Keep future data clean. Oh, easier said than done. And align your staff with the business units, all of which are important. But let's look at it in a little bit more detailed environment here. The data quality engineering cycle follows the Deming cycle of plan, do, check, act, or plan, do, study, act, depending on which way you like to do it. The idea is, of course, we're going to first of all identify the issues, define the business requirements for quality data, identify key data quality dimensions, and define the business rules that are crucial in there. Again, the idea is you don't just willy-nilly jump into these things, but you plan an assessment of that current state so that we understand what we're attempting to do and why in very precise terms, because these data quality challenges can get very much out of hand very, very quickly. And when they do get out of hand, you end up spending a lot more money on something than you intended to, where you really just needed to fix something very, very quick. This helps us to scope the problem, determine costs and impacts, and give us a good way of evaluating the alternatives that come around us. As we deploy or plan this thing, we then go in and use a series of data quality tools that we'll talk about at the end of the hour to inspect and monitor, find out what's happening there. But we can't do just the data. We also have to be holistic about it and find out what are the processes that are causing the data to, in fact, become incorrect on their way in. If we don't understand those, there's not a chance that we will ever do anything other than continue to bail water out of a canoe full of leaky water. We'll get to the canoe analogy in 2 more slides on this. Again, most people like to think of data as a big lake that's out there that they're using. Monitoring. Again, we need to put in place things that allow us to keep track of the data quality so that we understand as it's moving through our system, we can try to double check it. We've been very successful in our processes of helping organizations maintain better quality data, which helps provide them better fuel for their economic engines to go in place. And once we've identified what these problems are, we have to act not just on the data quality portion of it, but with the process reengineering pieces as well as any management, education, and other types of issues that come into play on this. Now, these concepts, as I mentioned before, and I want to give full credit here to our good friend Tom Redman, who's the person, as far as we know, that came up with this analogy of a lake. Data is, in fact, a lake in many organizations, and while there are maybe water problems in the lake, in many cases it's more effective to go upstream and find the source of the pollution than it is to continue to correct them at the lake. The other thing is, all of your data does not have to be perfect. We talk about Pareto analysis in many cases, which is the 80-20 rule, and it turns out that 80% of the data in most organizations is rot. It is redundant, it is obsolete, and it is trivial. And if those are the cases, why would we spend any time managing it at all? This allows us to bring scientific, economic, social, as well as practical knowledge to this. And even when we do it, we still see organizations that understand the various risks. This is a document from a project that we were put on to work on it. And notice here they have identified the quality of the conversion data as being very, very high. So people are starting to get the joke. They're starting to understand this as they go into it. Now, let's move on a little bit to causes and dimensions here. The real key for this is that there are 2 distinct activities that support this. Best practices depend both on practice-oriented activities, where you are working with the functional areas of the business to capture and manipulate the data, but another source of hidden problems, and if I hadn't already used the iceberg analogy, I would use it here as well, there are structure-oriented activities. If you do not understand this, you are missing an enormous part of what goes on in data quality. Quality data can only come as a result of both of these. Let's take a look really quickly. The practice-oriented activities here focus in on the quality of the data values. They're looking at things like edit masking, range checking of the input data, CRC checking, make sure you have a complete batch that has come across to you on this. Now, again, let me just dive in here for an example. We have some organizations where they have input data quality, and instead of having a well-engineered input system, what they have instead is a free-form text box. One of our favorite things that we observe in many organizations is that they'll put in a new system, and then they'll say, okay, now we're going to open it up to the users and ask the users to update their own data. That's probably the fastest way of getting to good quality data. Doesn't it seem reasonable? It absolutely does, but measurement after measurement after measurement, and yes, I'm pounding the table here, shows us that when you open it up and tell people to update their own data, the data is of lower quality. It is generally not a very good idea to do this. It allows imprecise, incorrect data to be entered in this. I found an example last night that I was just fascinated with. Talking to somebody about some Medicare, Medicaid data, which is my colleague Chekhovsky before class. He's a very, very interesting person in the analytics world, in the healthcare world on this. And he told me a story that in Richmond, Virginia, there are 3 women with the name Mary Washington who were born on the exact same day. Now, most of the time when people look at this, they say, well, there can't possibly be 3 people in the same city that have the same birthday. But you know what? Statistically, it bears out, in fact, quite well that a metropolitan area of about 2 million people would have 3 women with the same name who were born on the exact same day. And they all know each other now because, of course, Medicare and Medicaid keep calling them up and saying, hey, you're diabetes. And they go, no, it's the other Mary Washington who is trying to do this. Well, again, practice-oriented activities would certainly help us. One of the things we would clearly not want to do under those circumstances is set it up so that Mary Washington had the ID of their birth date and their name. Sometimes that sounds silly, but the country of Brazil actually did that with presidential elections about a decade ago, which meant that if you started that out, if you had a set of identical twins, they were going to have a problem unless their names were very significantly different on this. Let's move on now and talk about structure-oriented activities. Again, half of it's practice, half of it's structure. Structure talks to us about the quality of the models that we're putting data in, the data structures that we're putting it in, the quality of the data architecture that supports this particular organization. And you cannot be complete in your data quality engineering activities unless you incorporate both of these views in here. Structure problem symptoms that you'll see occasionally are the data is in the system, but we can't access it. We provide the correct data value in response to the wrong query, or when the data is not provided because it's simply inaccessible. The reason this is a challenge, and this gets to development methods as well, developers tend to focus within the boundaries of the system instead of across organizational boundaries. That's a very natural thing for them to do, and it encourages additional data silos that occur. This will affect the model qualities and the architecture qualities. And I'm going to say one step further on this as well, that we do a very poor job in general. I'm speaking of lots of the vast majority of the academic programs out there, and I'm a university professor, so I get to critique ourselves as well. We do a terrible job in most colleges and universities about talking about enterprise-wide data management and understanding the implications. Instead, what we do is we teach your future IT people how to build databases. So you know what they do when they get in the real world? They build new databases. Believe me, if there's a skill on the planet that we do not need more of, it's how to build databases. If instead we teach students how to integrate existing databases, then they would come to you all as the business folks and say, hey, where can I go get some data to reuse in these particular pieces? In fact, I'll go a step further and say that you shouldn't spend a dime on any sort of software development at all if you cannot answer the following question. What data items are you going to reuse from our existing inventory? And therefore, because we can't find them in our existing inventory, what data items need to be created? That's a very simple question, and if you can't answer that question, you do not understand your data requirements, and you should not spend a dime on software. I've had many, many people come to me after giving this talk and say, thank you, I managed to stop IT projects that were clearly headed off in the wrong direction by simply pointing out to them that they didn't fully understand the data requirements and that it would probably benefit them to spend a couple of extra weeks understanding the data requirements before we dive in. Imagine, if you will, the Scrum, the fun that's going on in the Scrum, the way people are working with Agile. And Agile, it works really well. And then somebody says, oh, wait, we don't have the data. And it stops, and you have to go find a data architect. And then you have forms to fill out because there's a governance process that's involved. Imagine if that had been done up front. The way to speed up your development efforts is to take data out of them. Do not let them start unless they know exactly up front how much they're going to do and how long it's going to take in order to do these things. I think I've beat that horse to death. You now see the data quality is a combination of 4 data quality dimensions: the quality of the data value, the quality of the representation, which mean they are practice-related causes of data quality. Similarly, we also need then to look at the quality of the data models and the quality of the data architecture. These are structure-related, and there isn't an analog in the real world. When you are building a house, the building inspector comes by the house before you put the walls up, before you put the roof on, and they do what is called a foundation inspection. If your foundation doesn't pass inspection, it means you should not spend any more money putting up walls or a roof because the foundation is incapable of supporting the load that you're going to put on them. Similarly, we need a foundational inspection for new systems because if we don't understand the foundational piece is not sufficient, we will build and spend a lot of money on these things, but not, in fact, deliver the value that the business is looking for. Let me give you one example of this, and not to pick on SunTrust. They are our bank. They do our payroll every week. I'm very pleased with SunTrust banking, but I have to point out a little error that occurred a couple of years ago in here. We got this, one of our data engineers got this letter from SunTrust that gave him a gift card. He opened it up and brought it around to me, knowing how much fun I would have with it. Because the bank didn't know that they had made an error, we got on the phone with one of the bank's customer service representatives and said, tell us where we can spend this gift card. Can we go to the movies? Can we buy food with it? You know, da-da-da-da-da-da-da-da. And finally, at the end of the conversation, the customer service representative said, did we really send you a gift card for $0? And we said, by golly, that's exactly what happened here. You send them a card for $0. We were hoping it was an overrun and there was actually $1 billion on the card, but we didn't know it. Of course, tools alone could not have prevented this error, although certainly some range checking, just back at the Mizuho example, would have made sense as well. And some people can lose confidence in the bank's ability to manage the customer funds. We did not with SunTrust. We were very pleased with them as a bank. It was an aberration. I'm absolutely certain on that. So we've talked about these 4 dimensions of data quality and, again, divided them up into the practice-oriented versus the structure-oriented qualities here. Again, the data value is the quality of the data that is stored and maintained in the system. The data representation, however, is different. It's how it is shown. So in the previous example with that $0 SunTrust card, I was trying to get them to say, oh, yeah, we really should have $100 or $1,000 or $1 million out there on the card. It just doesn't show up very well. So, go ahead and spend it. Of course, that wasn't the case, again, in this particular instance. And then, of course, the model quality, the architecture quality, we need to know how people understand these things. And again, if we only give them one course in this area, it's very unlikely that they will, in fact, be able to be quite expert at it. So we're reliant on professional organizations such as STAMA to, in fact, raise the quality of the profession around here and to make people understand what it is we do in these areas. Now, if we're going to get into effective data quality engineering, again, knowing now that we have to understand all 4 of these dimensions, most organizations tend to focus in on what they're doing close to the user. You can see the data representation quality because it shows up on your smart tablets, your phones, whatever it is that you're looking at, your web browsers. That's what they see. So that tends to be where most people respond to these data quality problems. We can see also that they are related to data value problems. That's how it's maintained in the system. But again, the model quality and the architecture quality, I've already talked about it in terms of how they use. Now, this is the same chart, but I've expanded it now to show, in this case, the actual attributes that are there. The attributes of data quality with respect to representation are listed there. Completeness, correctness, timeliness. I'm not going to read them for you. You can read them yourself. But here, again, you'll see on the left-hand side of this chart, these are things that are closer to the user, whereas the things that are on the right-hand side of this chart are closer to the architect. They are more abstract in nature. But notice the relationship between these various dimensions. A data architecture spawns one or more data models. And again, the quality of those data models is variable in this case. Each data model spawns multiple data values, and each data value can spawn multiple data representations. So if I'm working down here at the close to the user end of this thing on the left-hand side of this chart, it's kind of like being at the bottom of Niagara Falls and complaining about the quality of the water. Goodness, what am I going to do at the bottom of Niagara Falls about a data quality problem? I certainly can't wait until the falls freeze over, although interestingly enough, this year they did. First time in a long time. Global warming, climate change, whatever we're going to call it, is making things very, very interesting. But let's look at a particular structure-oriented problem just to illustrate this section. Now here, turns out that the city of New York has an interesting problem in relationship with their trees. They have about 2.5 million trees in New York City. And in the 11 months from 2009 to 2010, 4 people were killed or seriously injured by trees falling in Central Park alone. And of course, every time that happens, it hits the New York Post. Now, for years and years, oh, by the way, there's lawsuits against the city and all sorts of other things. Forget about the fact that people are actually hurt on this. We can put it in a risk management context very, very easily. Now, the belief, the arborists, the people who work with trees, believe that pruning and otherwise maintaining these trees can keep them healthier and make them more likely to withstand storm, wind, et cetera, decreasing the likelihood of damages. Until recently, they had no data to back it up. So they took a big data approach to it, interestingly enough, and they called it the big tree problem, which was good. So the question was, does pruning the trees in a year reduce the number of hazardous tree conditions in the following year? And the first answer to that question was, we can't answer the question, because they had lots and lots of data, but they had data that was structured incorrectly. The pruning data was recorded by block. The cleanup data was recorded by address. Each tree, of course, had its own unique serial number. No, I'm joking. Trees don't have serial numbers. They have no unique identifiers in there. And I imagine if the people in the city of New York tried to run around and label every tree, they would get all sorts of derision from the local residents who would be there. However, the group, after downloading, cleaning, merging, analyzing, and intensely modeling what was going on with the system, they were able to come up and say that pruning trees for certain types of hazards caused a noticeable 22% reduction in the number of times the department had to send out a crew for emergency, read overtime, cleanups. Now, the best data analysis generates another series of questions, and of course that's what it did to this group. They went back and said, hey, we can't prune every block every year, so what can we do to do this? Well, as part of their data quality initiative in this area, they started building block risk profiles. So they would say this block is more at risk than this block, based on the number of trees, the type of trees, whether the block is in a storm zone or other sorts of zones that are in there. So having the data at the right level of granularity, having these structure-oriented problems here helped New York City reduce the cost to the taxpayers of having all the beautiful trees that they have in New York City. Let's move on. Now we're going to talk about quality and the data lifecycle on this. I'll give you another example. This is from my own bank here. The letter from my bank comes in and says, by the way, notice it is undated, which is a little scary just for starters. And if you look real carefully at that letter, you'll see it actually looks kind of wrinkly. And the reason for that is because I took the letter and I crumpled it up and threw it away. I said, I am not a Bank One customer. That came in a Bank One envelope. However, when I opened the mail, notice it says, by the way, you may have heard about a recent merger between Bank One and JP Morgan Chase. Actually, I hadn't, which is why I threw the letter away in the first place. I saw something on the news, and I was able to go back and retrieve this letter. Yes, that's how long I've been doing PowerPoint. So I pulled this letter out of the trash can, and you can look at it here. It's got a little bit of problems. Now, maybe they were just really, really interested in trying to find out whether they could use up the rest of their supply of Bank One envelopes and Bank One letterhead, but I don't think that was the case. Twice in the letter they repeat, please be on the lookout for any upcoming communications from either Chase or Bank One regarding your Bank One credit card or any other Bank One product that you may have. In other words, we're putting the onus on the customer. Not a good idea. The problems are, of course, I initially discarded the letter. I was not happy about reading it. That seems to me that it's a burden on the customers to say, hey, we're merging and we're going to change our name right now, not giving you any time to switch over on that as well. And it claimed that Chase Bank had some very significant quality problems that were associated with the merger that have actually been well documented and solved at this point. Chase is a very good organization from that perspective. So now let's get to the second polling question that we have here for you. Does your organization use what we call a structured or formal approach to information quality, or are they saying they are but they aren't, or simply no? Those are your three choices. So again, take 30 seconds here if you will, and Megan, let us know when we've got the answer to this so we can now start to dive in a little bit more closely on data quality life cycles.
All right, we've got some answers coming in. We've got about 20 seconds left until The poll is up, so I'll reveal the answers at that point.
We appreciate you guys participating here. I know some of you can't actually do it because you're driving in your cars and watching your webinar on your iPhone while you're moving on the highway, right? No, I'm just kidding. Tony would just be appalled at that if you do. Everybody's safely parked behind their cubicle somewhere and working on this stuff. Oh, dead air. Don't let dead air happen.
Yeah.
All right.
All right.
We're really
so
still here, honest.
Let's see here, and there they are. You should be able to see them now.
So about 20% of you say that you're working in a structured environment. That really mirrors our findings as well. About 22% of you are working on stuff, but it's kind of ad hoc, and no, not really in some of the other cases on this. So again, thank you for your input on that. Let's move on and dive into the data quality cycle. Now, I mentioned Tom Redmond before. Tom is notable for a number of things. He's the first person to use the term data-driven, first person to get Harvard Business School review to start talking about, specifically talking about data and data quality things, and he's just done some wonderful work there. This was his original concept in his book on data quality, and it seems natural. Data acquisition cycles, and then you have a storage component, and you have some data usage cycles. But upon reflection, we've discovered that it's really a little bit more complicated than that. I'm going to give you our updated model on this and finish it off in a way that I think will taste a little better for you, because this is kind of complex. First of all, before you can create data, you have to create metadata. So metadata creation happens first, where you create data architects and models. That moves us down to an activity we call metadata structuring, and then data creation can occur where we populate the models and storage locations with actual data. That data can be stored in our organizations. It can be utilized, and when we utilize it, we may or may not manipulate it. If we manipulate the data values, they can be put back into the thing. They're stored, restored values, values that are stored again. Then we can look at data assessment. We may want to evaluate that, and that may lead us to manipulate it. So again, it can go down that way. We may also refine the data, and we take and correct the value defects and fix them as they go forward. However, in many cases, and in our experience, it's more often than not, the metadata itself needs to be refined. And if we don't understand how that is refined and don't refine the models, then we have no ability to address the structural causes that I stressed so much in this webinar. Similarly, we need to refine the architecture as well in there in many cases. So again, being careful about all of that. This is our newer data quality cycle on this, and I'm showing the same diagram here with just talking specifically about what are the quality issues around this cycle. This cycle didn't end up being very cyclish, if you will, and so they had me redraw it into a very nice cycle this way. This is not quite as precise as before, but you'll notice two entry points for this new data quality lifecycle model. The upper left-hand corner is the starting point for new systems development, where you create metadata, define the architecture of the models, work your way through metadata structuring, data creation, data utilization, manipulation. And for existing systems, we also start in the bottom right-hand corner, data assessment, refinement, and then metadata restructuring in order to do this. Now, this process is what we call re-engineering of data. Re-engineering got kind of a bad term because it became a term of art for any kind of change in most organizations. That was really a bad idea. But what we did discover was, in fact, that we needed to re-engineer this. And there is a formal definition of re-engineering, which means first using and understanding the existing strengths and weaknesses of your data before you go back out and use them again. You can't blow up the old system. You need to look at it and say, what are the good things about it? Let's reproduce them. And what are the bad things about it? Let's avoid them as well. This is what we mean by data re-engineering, by first reverse engineering the data and understanding it thoroughly before we go back out and put new data systems in place. Again, there'll probably be some questions about that. We'll happily take them at the top of the hour, which we are 10 minutes away from as we move on this. So let's get to our third polling question. Do you use meta models, modeling tools, or profiling to support your information quality efforts? Just trying to get an idea of the penetration of these tools. The vendors in general, I'm not sure why I have a copy of a picture of a person drinking. Is that, Megan, did I do that one?
I believe you did.
Oh, my goodness. I have to watch my clip art sometimes. The way I do it, by the way, is I go out to Google Images. While you guys are filming this, I'll tell you this. We will go out to Google Images and type in the keywords that are on here. So I probably put in something like information quality and got this guy drinking back and said, oh, that's clever. Anyway, what do we got in the way of responses, Megan? Simple yes.
All right, they're still coming in. We've got about 1 second left. Looks
Be
like
patient, Peter. I hear you. Yeah, that's right, exactly.
Yeah. It's all in, so let me get the poll results up for you. Let's see. Should be up in just a second.
You could tell us if you wanted. It's a simple question. There we go. Okay. So still, 43% of you are using tools, which is great. We don't know about 30%, and a good third of you are not quite using tools yet. So let's dive in and look at specifically at the tool sets that we have in this area. And I have to tell you that the key to this was work that we did when I was at the Pentagon in the early 90s. We funded some research that went in to develop the basic algorithms around data profiling. We did this because we had done a study at the Department of Defense that said we have some quality problems, as do most organizations, but the DoD was spending a lot more money than most organizations to do this. So the work was done by a PhD out of Columbia named Dina Bitton. She's a wonderful colleague, and we owe her a vote of gratitude for helping to develop this particular approach. Notice I'm showing on the chart here that you could do this in top-down or bottom-up, or if you want to do both of them, that's great. Top-down, of course, comes from management. Bottom-up comes from you all who are the people who are really, really concerned with the data in there on this. It's easier to do it in top-down because you have a lot of management support in order to do this, but many times you start out with bottom-up in order to do it. Now, first thing that we want to do is look at measures that are around this strategy. Again, finding a smidgen of the organization. Don't try to be comprehensive. Again, pick an aspect of the business, one sort of critical in terms of its impact, and let's evaluate the data-dependent elements to create the processes that are associated with it. Remember, you can't look at just the data. You have to look at how the data gets to these systems. You need to be able to list any associated data requirements that are there, which people probably don't know about as they're inputting the data. And then you want to associate the dimension of data quality, which will preclude and include certain specific approaches to do this. I'm going to describe the process for measuring conformance and specify some sort of acceptability threshold. And I'll tell you a little quick story here about a hospital in the middle part of the country whose director came down and called an all-hands meeting and said to everybody, hey, you guys, we're going to do some really interesting work here at this hospital. We're going to do knee surgery. And you guys have been doing so much knee surgery that it's just phenomenal. We're going to have tons and tons of things. We'll be the knee surgery capital of the Midwest on this. And left the room. And the physicians in the room kind of looked around and said, I'm not doing that much knee surgery. Are you doing knee surgery? No, I'm not doing much knee surgery either. I wonder where the information came from. Well, guess what? The default hospital admission code was knee surgery. Oh, my goodness. Here's a very smart administrator who looked at the data that they were given and said, we're doing so much knee surgery, we need to expand our efforts, not realizing at all that this was a practice issue that could have been corrected very simply by allowing no default to be the default entry code to the hospital, forcing people to pick something off of the list and probably providing higher quality data as a part of this. Now, what we're looking for is evaluating the various data quality service levels, and it's okay to speak in formal terms here and to use service level agreements on this. If you can set these things up, they can start to be put in place as to whether these things are correct or not. If you just say the data sucks, and I was working with a good friend of mine this week who works at DMAS down in Richmond, and her story was very, very nice. She said, well, when I got here, they told me this data sucked. And I said, what does data sucking mean? And they said, I don't know. Our users don't like it. And they tell us it sucks. So she went in and measured it and found out their data was only 2% in error. All of a sudden, it went from the data sucks to the data is 2% wrong. And 2%, they can now make a business case as to whether they should, in fact, fix it or not. Again, you can put together the picture that you need to do here. If I've got an agreement in place, we can measure to that agreement. If we're not reaching our agreement, we can decide whether we need to relax our standards on this or whether, in fact, we need to go on and increase the effort that's being put into these areas. Excuse me. Again, measuring and monitoring the data quality very important. We can look at it from the context of business rules. We can apply the granularity to data element values, instances or records, or to the data set as a whole in order to do this. Excuse me. Sorry about coughing towards you guys. So here's our overview of data quality tools. They really fall into 4 categories: analysis, cleansing tools, enhancement tools, and monitoring tools. And the principal technologies are profiling, parsing, and standardization. I've already given you a parsing example on this webinar. Data transformation, identity matching, and resolution, which turns out to be a huge component of big data. So as you're looking at that, we'll probably get around to doing a big data and quality webinar in one of these days. Again, enhancement and reporting of the data. Let's look at the data profiling. First of all, here again, these are the algorithms I described to you earlier on which many of these tools are based. You can take these tools and look at any structured set of data and come away with a logical third normal form of the model, which gives you an understanding of what the structure should be, and you can compare it to the structure that is and decide what is the right structure. In addition to that, of course, you can look at the various values. If you're not familiar with these tools, they are worth checking out. They're often called discovery or data analysis tools. If you're a SAS programmer, think of ProcFreak on steroids. Really, really good ways of describing this, or just using some of the functions of Excel and a pivot table. By the way, you do not need to spend a lot of money on these tools. Again, Excel will do a tremendous job for you if you're able to do this. Even down to the iPad implementation of Excel, which is a really, really beautiful piece of work. Congrats to Microsoft. Sorry you blew it on PowerPoint and Word, but the Excel port to the iPad is a really, really nice process in here. So again, we can understand the contextual, the semantic layers. We can actually do different types of modeling with it and understand it so that we now can get some factual information about our profiling tools. And one of our favorite tools here is a company called Global IDs that does much of the things, everything that you see here actually in this in terms of how it does it. And interestingly enough, the company has put this together using a big data technology. So we're using big data to apply to big data solutions, which I just love. One of our favorite tools that we do on our Tech Fridays at Data Blueprint here. Second tool is the parsing and standardization components. This is the idea that we're trying to get to things where we understand which of these things doesn't belong in this list, right? And we can look at this, again, just simple things like look at street. And there's 4 different ways of implementing the word street out there in your data sets. And if you're parsing for streets, you need to be able to have 4 different queries, or at least 4 options that can be returned by that query. Data transformation, again, here is the idea that these are sort of automatic things. When we grab an X, it goes to Y. Think of this as an ETL, but an ETL focused not solely on movement of data, but in fact on transformation of the data. The identity matching and resolution component here is a beautiful piece of work. We can do this in a number of different ways, understanding exactly how everything goes to play on all these tools so that we can find where are things associated with other things. Again, this is getting us towards the structural. You can see there's a deterministic and a probabilistic component. Again, I won't do these as a reference. Data enhancement tools, again, another component here that we look at where we say, can we enrich the data? I know it comes in just saying 42, but if I could add a tagline 42 in the context of the meaning of life, universe, and everything, we would now have a really good idea of where that goes, how we're supposed to use it, where it, in fact, should reside as we're looking at it. And then finally, reporting tools, which people have been using for years and years. Show me all of the trades that took place where you had 1 yen in value. Well, again, it's an absurd proposition. If you're in Japanese trading, that's way below penny stocks in terms of how to do it. But by golly, if you can catch that stuff early on, you will catch a lot of errors. And the really interesting thing about the Japanese culture is that when I visited Mizuho Securities full 10 years after this, they were still, I don't want to say ashamed, but they were cognizant of the fact that their company's name had been associated with this. And they had really taken this to heart and changed the culture of the company. It's a magnificent story. Yes, they had an oopsie, but boy, did they really get how to do this in the long run and have done a tremendous job ever since. So here's our overview again. The key is you really do want to start to promote data quality awareness. You want to understand these various requirements that we're putting in place. We really, really do want to get in and figure out how to start using any tools. You do not have to spend a lot of money on data quality tools. Excel doesn't cost much money, and Excel is a very, very viable data quality tool, particularly for diagnosing the problem that's in there. You can start to identify these metrics, the business rules that go in with it. You can start to test and validate the specific data quality requirements. We can start to implement service levels informally within groups. You do not need to ask for permission. It's better to ask for forgiveness in this case. You can set up things that start to manage, measure, and monitor data quality. In fact, what I like to do with organizations is to say to them, take this sign that says, I am responsible for all the data quality in my organization, and put it on your desk or your virtual cube or the bottom of your email signature if you work virtually. And sooner or later, somebody's going to come along and say, hey, how did you become responsible for data quality for this whole organization? And you say, well, if not me, then who? And pick up the sign and hand it to them and say, you can give this to somebody else. It's a tough job. It requires a lot of work, and it's non-trivial in terms of its impact on the bottom line. Well, if that's the case, here's your sign. Now what are you going to do with it? So we're back at the top of the hour here. Again, data quality engineering is a process to understand how we are going to apply an engineering discipline to the process of improving our organization's data quality in this. And now we get to the part of the program that I really enjoy a lot, which are the questions and answers. Megan, back over to you.
Thanks, Peter. That was a great presentation. Now it's time for a Q&A, time for you to ask your questions. So just click on the Q&A window feature at the top of your screen. You should be able to submit your questions through that Q&A window. And we've had a few come in already, so we can jump right in. The first question is, how would you counter Mr. Scott Ambler's contention that we data people are nothing but obstacles to flopping out application systems as
Agile.
Thank you. Yes, and quickly as programmers won't want.
So, first of all, I don't think they're quoting Scott correctly on that. Scott has presented at our conferences in the past. He is a wonderful speaker, and if you have not had a chance to go see him, I do think that he understands data a lot more than the question implies there. But he is correct about one aspect of things, and that is that if we simply sit around and whine about what's wrong instead of actually trying to do something about it, that will not work. So I'm literally, again, across the river from the Pentagon, where I worked for a number of years on data quality problems for the Department of Defense. And we were able to solve things. And I have never met a group that couldn't go in and make some impact in data quality in these areas. So I don't think that Scott actually characterizes it that way, although I do understand how in your middle of your Agile process, and again, Agile is a good process. It works very, very well in order to do this, but that if you have to stop and develop a new database in the middle of that, the only possible outcome is that you will end up with yet another pile of redundant, obsolete, or trivial data in your organizations. The average organization has their customer data spread across 17 different databases. That's the average organization. So while Scott is, I think, correct to focus in on the good things about Agile and also to say that we need to do more than just whine about the problem, I think he's actually done some very deep thinking around that process. And I don't think that his characterization, as posed by the questioners, but I do understand the sentiment on this. And we data people do have a reputation for sort of complaining without actually doing. The groups that I've seen successful take those complaints and turn around and do something about it. And when they start to do this, this becomes the bottom-up approach to their data quality efforts, and they can, in fact, achieve some very significant results on that. Scott has written extensively on this subject. He's got a really nice website out there. So if you want to carry on that particular dialogue, give him a ring on that, and I'm sure he'd be glad to respond. He's a terrific individual.
All right, great. And next question is, what is CRC?
CRC is a cyclical redundancy check. Thank you for asking that. We use too many TLAs. That would be three-letter acronyms on these talks as well, so good for catching it. A CRC check tells you whether a batch of data came through correctly or not. So if a frame of a movie comes in and it has an error in transmission that introduces some noise into the process, the way the TCP/IP protocol works on the Internet is that it will recognize itself because the CRC check is incorrect. It will say, I didn't get a good block of data. And what you will see is that that block of data will be retransmitted from the last hop to the present hop. That's not the only use for CRC data, but that's how it works on the internet in order to do that. By the way, the internet actually mirrors the way the physical world works in many, many ways. There's a terrific book by Dawkins called The Selfish Gene where he talks about this issue entirely in there. It's just a fascinating, fascinating world that would get too esoteric for us, but yes, very definitely.
All right, and next question is, how has the situations with the NSA had an impact on the way people think about DG, which data governance?
I think a couple of different things go into that question. It's a really good question. Of course, talking here as I am in Washington, it's a question that's on a lot of people's minds. So let me give two perspectives. First of all, the word metadata has now come into common use. We used to say, oh, don't ever tell managers about metadata. But when the President of the United States has press conference after press conference where he's talking about the fact that they're only gathering the metadata, they're not actually listening to your phone calls. I don't know anything about what the NSA is doing. We make that perfectly clear on that. But that it does start to enter the vernacular. People do start to understand it, and it becomes more of a popular topic. So I think that in general, the awareness of data as an asset has been a very big help. Let me talk about another aspect of the Snowden thing that many of you may not be aware of, though, and that is that Glenn Greenwald and some of the others who, in fact, talked to him about this talks about the way he established his credibility. Because you can imagine just getting a call out of the blue and this guy says, hey, I'm here, I've got some secret stuff from some places inside the federal government that they don't want you to know about, and I'd like to give it to you and become a whistleblower in that sense. They said what he had given them were a series of flash drives that were unbelievably well organized, that there was an absolute taxonomy of the information that he had organized and carefully, I'm going to use the word curated because it's an absolutely appropriate term for what he had done. He put together probably one of the best taxonomies of what was going on in the intelligence community that frankly I would pay money to have just so I don't have to recreate it the next time I work in that particular space. This is how he established it. Greenwald said that when he would go down a directory and it say, this is about subject X, and subject X has 3 components, X1, X2, and X3, and when I go down into X1, there are 7 components of X1. And again, they're all laid out methodically, carefully, and correctly from a metadata perspective. And Greenwald said there was absolutely no question at all that this guy, A, had the information that he was claiming to have, and B, that it was really, really significant stuff. As we all know, that is now taking an import on this. Now, let's take another part of it, though, which is to say that if the NSA is monitoring metadata phone calls, and they've pretty much admitted that they have certain aspects of that they are doing, and I loan my telephone to Megan, that could be a thing that might actually be hazardous to Megan's health. Megan, I'm certainly not threatening you. Please don't take it that way, but you know what I'm talking about. If somebody decides that they want to follow me by my phone and I give it to you, that could be a problem. So, again, opening up other whole worlds of possibilities here in order to do that. I'm going to say one more thing about the smartphones, too, which is that the smartphone sensors that we have can actually identify the gait that we use, our walk. As we walk around, our gait is as unique as our fingerprints, our voice prints, and our retina scans. This is really the basis for wearable computing. Everybody keeps talking about iWatches and things like that, which are good things, and we look forward to the technology developments that come out there. But more importantly, when we can actually have something that says, I know that it is on Peter's wrist, that means authentication is going to become a much easier task, and it will become much less onerous. We won't need these 64-character passwords that we have to put in place and then, of course, write down, which defeats the whole purpose of security. And by the way, quality and security have huge implications. If your customer data is in 17 places, how would Target secure it? I'm not saying Target had their data in 17 places, but they clearly missed out on the fact that their main customer database, which is an awful lot of data on their best customers, was leaking out slowly. It'd be kind of like coming home at night and seeing that you had a gas tank full of them, the gas tank's empty by the next morning. Of course, it wasn't really a matter of emptying the database. They didn't erase the old customer data. But still, it was a very, very, very large volume of data that kind of leaked out through the air conditioning ducts, if you will, in Target. I'm really sorry to see that their CIO took the hit on that one. Somebody, was bound to have their head cut off on it, but I don't know that the CIO would have been the person to blame for that particular instance in there. We're getting off topic. What's the next question, Megan?
We actually had someone asking about who the author was that you were talking about from the Harvard Business School, but they want to know the book that you were talking about.
Yes, absolutely. Tom Redmond is a friend and colleague. You can see his profile on our website out there at datablueprint.com. And Tom has been a wonderful friend for many years and actually was inspirational in terms of getting people thinking about this. So the original book here was Levitin and Redmond in 1993. If you Google that, it'll come up. But Tom has a much better book on the topic now, which is called Data Driven. And in fact, Tony, if I remember a couple of weeks ago, Tom did a really nice talk on this particular webinar channel. And it was very, very nice. So that answers that question. Get a chance to hear him. He's a great speaker.
All right, great. The next question is how to reconcile agile development approach with need for design analysis, which has its own life cycle and not agile most of the cases.
Oh, I'm so glad somebody asked that question. So we've been perpetuating a fiction in the academic community here for many, many years. And the fiction is simply that data and software can be developed at the same time. It's absolutely incorrect. It can't be done. It never should be attempted in the first place. The only time it can work is when your data doesn't cross the boundaries of the existing system. So I'm going to shift presentations here and pull up another chart just to illustrate this process. I hope I can do it fast enough so that you guys don't get bored in the process. But Megan will be sure to include this in the slides as we get them out there. So hold on while I visually disturb you guys by flipping through 1,000 slides here real quickly, and let me find the one that I'm looking for. Getting closer to it. There we go. So key, of course, the question was, how do we reconcile the fact that we teach everybody in college and university who takes IT courses that data and process can be developed at the same time using the same life cycle? It is wrong. It's fiction. It never existed in the first place. The only reason it was written that way is because somebody grabbed an article that was incorrect and reproduced it. And that happens a lot in the academic world. It's a problem. When we are developing systems, we are fundamentally working with an activity that creates things. And when I say create, it's we identified a business gap, a capability that the business doesn't have that we'd like the organization to have. So we create that capability. That is the fundamental focus of systems development. However, data doesn't work that way. Data persists. Data evolves. Its change is measured in years. System development activities are measured in 2-week sprints in some organizations. They are fundamentally incompatible. The only possible result of following a simultaneous development of data and software, unless the data doesn't go beyond the system boundaries, is that you will create more disparate piles of data. Data evolution is separate from, external to, and must precede system development lifecycle activities. If you do anything different, you will end up with a mess, and that's what we've been doing, in fact, looking at the mess. So I'm going to grab that slide and put it in here. Since the question came up, I'll stick it in the appendix of these slides so you guys can have a copy of it. I hope that answered the question. It's a little bit strong, but we do need to recognize that if we continue to teach people the wrong things, they will continue to try and go out and do what we teach them, which in this case turns out to be absolutely wrong. I've got a lot of other reference material in here, by the way, just so that you all know. There's recommended readings. I've got the full definitions of the data quality dimensions and things that are in here as well. So please use this deck as a reference deck for you. Again, data quality dimensions, data value, representations, model qualities, architecture qualities, et cetera, et cetera. It's all in this particular deck. Megan, next question.
All right, the next question is, what would you say is the largest roadblock to data quality?
Well, that's an interesting question. I think that the largest roadblock to data quality is the fundamental perception that IT is responsible for data quality. And it really isn't. Data quality is not an IT function, it's a business function. IT is not capable or situated to put a value when things are wrong on bad quality data. IT is not able to understand how to do this because we've taught them incorrectly for years and years. And finally, IT incorrectly, that all of IT projects be managed as a project. Data is not a project. Data persists. Projects have a beginning and an end. Data, by definition, generally doesn't. It has a life cycle, as you see, but it's a beginning and an end. It's certainly not within a development context in there. So understanding of the business thinking that IT is taking care of data, and IT saying, if they can log onto the servers, my job is done, it's going to continue to become a major fundamental hurdle, because then they turn around to the CIOs who are already slammed with tons of other things to do, and we tell the CIOs, by the way, you need to fix data quality. Well, they don't have the knowledge, skills, and abilities to do this. The engineering discipline isn't there. The architecture is not, in many cases, understood at the data level where it should be in order to make a difference. So again, I have a strong opinion on that, as you can tell. Feel free to disagree with me on this.
All right, great. And the next question, is dealing with data quality really necessary in an integration project?
Well, if you're integrating bricks, no. Integration, by definition of systems, generally means of systems and their associated data. And it's relatively easy to integrate the systems from a technical perspective, but the data, by definition, must be correct at its most granular level. Again, if you move a number into a text field, no problem. But if you move text into a number field, it doesn't work. Some of you remember the old OC4 or SOC 7s that we used to get when the mainframes blew up. It hasn't changed. If you put the wrong type of data in the wrong type of field, it doesn't work. Unexpected things happen. Abnormalities occur. And when that occurs, it's a big problem for everybody. Absolutely. Next question.
Okay, it looks like we're actually out of questions for today. So
wow, 15 minutes. We knocked them out quickly today.
Yeah, we ran right through them. Thank you, everyone, for participating in today's event. We hope that you've enjoyed it. Thanks again to Dataversity for hosting us. Once again, you will receive today's materials within the next 2 business days. Our webinar next month will be Data Architecture Requirements. Hopefully you'll be able to join us for that as well. As always, feel free to contact us if you have any questions. Thanks, everyone, and have a great day.
Yeah, let's not forget, too, a bunch of us are going to be meeting in Austin at the end of this month at Enterprise Data World, where Louis Broom, my business partner, and I will be talking about developing a data-centric strategy and roadmap, along with, gosh, Tony, how many other presentations do we have on this? Probably several hundred that we're going to have. It's one of those things where you go into and you never feel like you have enough time or material to go in and see everything. So what most organizations do is they send a couple people so they can at least multi-track in order to do that. But again, our big conference of the year in Austin coming up at the end of this month. We hope we see everybody there. Thanks for listening.